So in this video, I'm going to cover the 20 problems on your toolkit. The reason we're starting here is that you already have the problems marked, or should have the problems marked at this point. And what we're going to be doing is using those pictures that came from the activities to make some decisions about what the missing angle measurements or side lengths should be based on the things that are congruent to each other. So in problem number one, which is a parallelogram, says we have a perimeter of a parallelogram, and so based on the picture above, if you haven't already marked it, if you think about marking this picture based on the picture above it, and then use that information to try to find the x value and the y value. And problem number two, again, is our parallelogram, and with this one we're working with angle measurements, and so based on, again, that toolkit picture, which angles are supposed to be congruent to each other, mark the picture, and then try to figure out the answers. And again, if you don't need to mark the picture, if the marked picture above it is enough to help you figure out what angles are equal, that's fine. But as I go through the problems, I will generally mark most of the information just, again, to clarify the answers. So as you work through the problems, use the pictures to help you decide what things, again, are congruent, whether they're angles or sides. So go ahead and complete the parallelogram problems, and then turn the video back on when you're ready to go through them. All right, so for the first one, the parallelogram, opposite angles are congruent. So these two angles here are congruent. So anytime I see a number, what I'm going to do is I'm going to be looking at the picture from our toolkit and decide, what other sides or angles must also have those numbers. So the 73-degree angle comes down here. If they were asking for this angle here, which actually is marked differently, as well as this angle here is also marked differently, just kind of clarifying what happens if I'm looking for this angle instead. The angles that are opposite each other are equal, and the angles that are next to each other actually add up to 180 degrees. So going back to our conversation that we had earlier about parallel lines, what's happening here is either the angles are the same or they add up to 180. In this case here, opposite angles are equal, and then the angles that are next to each other add up to 180. So for this problem here, x is 73 degrees. For the parallelogram, we have a 26, and your picture hopefully shows you that these two, the opposite sides, are equal. So these are both 26s. And then this length here is y, and this length over here is also y. And so opposite sides going from left to right are also equal. So my perimeter is 168, and I'm taking away two 26s. That's the top and the bottom, which is 52. So I'm left with 116. Take away the 52. And then we have two y's, and so each y is going to get the same amount. So each y has an angle measurement, a length of 58. So each y is 58 long. So y is 58. In the second picture, when we created this problem, we actually did a rotation around the midpoint, and as a result, this angle here is down here. So that's a 25-degree angle. And then this angle here, again because of the rotation, ends up here with where y is. And then for the final one, this angle here and angle x are the same. So to find x, we have two of the three angles of the triangle. So these two angles add up to 148. So that means angle x is what's left of the 180. So 180 minus 25 minus 123 should leave me with 32 degrees. So x is 32. and y is 123. For the remaining parallelograms, in this problem here, I see an x, and so this segment and this segment are the same length. Also, I see a 21, this length here and this length here are the same. And so x, unless we have, and I'm sorry, misread that. It says AC is 21. So the length of AC is 21, so that means that since these two lengths are the same, x is going to be half of that. So this is 10.5 and this is 10.5. Sorry about that. And for the last one, we have a parallelogram. So in a parallelogram, based on our toolkit, opposite sides are equal. So this side here and this side here are equal. So that means the top here is y plus 5. And the left side and the right side are equal. So this side over here is 2y minus 3. So the perimeter is 52, so if I add up all four sides, they should equal 52. So I have 2y, a third y, plus 2 more y's, and plus another y. So that's 2, 3, 4, 5, 6 y's. And if I add the numbers, negative 3 plus 5 is 2. And this negative 3 plus this 5 is 2. So I have a 2 here for these two and 2 for these two, which means that adds up to 4. So 6y plus 4 is equal to 52. And then we solve for y. So if I subtract 4 from both sides, 6y is equal to 48, since 52 minus 4 is 48. And then divide both sides by 6. And the length of, or the value of y is 8. The next two sets of problems are about trapezoid. There's not a lot of things about trapezoid based on our work so far, but go ahead and look at the 4 trapezoid problems and the 2 pictures from our toolkit, and then see if you can figure out those answers. Turn the video back on when you're ready to continue. Alright, so you have an isosceles trapezoid. Since the non-parallel sides are marked equal, whenever that happens, that means we have 2 sets of equal angles. So the angles along the parallel side are equal, and then the other angles along the other parallel side are equal. So that means x is going to be 123 degrees. And then along the sides that are not parallel, these 2 angles here are going to add up to 180 degrees, which makes this angle 57, and makes this angle 57. So y is 57 degrees. Problem 6, we have a pair of equal sides. So that means these 2 sides are both x's. So if 102 is our perimeter, and we have a 26 that we already are given, and we're given a length of 42. So of the 102, those 2 sides make up 68. So what's left is 34. And then you take 34 and divide it by 2. That means each value of x is going to be 17. This is not an isosceles trapezoid, which means these 2 angles here will not be the same number, and these 2 here will probably, again, most likely not be the same number. There may be that rare case out there, but Generally speaking, these angles will not be the same. But what is true is that these two angles along this non-parallel side have to add up to 180 degrees. So that means this angle here has to be 125. And these two angles here along this non-parallel side also add up to 180 degrees, which makes y 79 degrees. So y is 79, and x is 125. And then the next problem, we do have an isosceles trapezoid now because the non-parallel sides are marked equal. The angle along the non-parallel side, those add up to 180. So these two angles here plus this angle here has to add up to 180. So if I take 180 degrees, take away the 31, and take away the 65, which is 97 degrees, what's left is 83 degrees. So angle X is an 83 degree angle. Now the angle at the top are the same. So this angle here, Y, and this angle here, which is made up of two pieces, are the same number. So that means that Y is going to be 31 plus the X angle of 83 degrees. So the value of Y will be 114 degrees. All right, so that's the two trapezoid problems. So again, with trapezoid, the biggest thing will be either looking for a missing length if you have a perimeter, or understanding that with isosceles trapezoids, you have two pairs of equal angles and two pairs of supplementary angles, which means they add up to 180. With a trapezoid that's not isosceles, generally there are no congruent angles, but you do have two pairs of supplementary angles. I'm going to go ahead and close this video out and start a second video for the remaining problems. So if you would go ahead and work on the kite problems, there are 4 of those, and go ahead and when you're done with those, click on the next video and listen to the discussion how to complete those problems.